In this video, we'll look at what does it mean for a function to be increasing or decreasing. Okay, so what does it mean to be increasing or decreasing? In a way, is exactly what you think. You're increasing if you're getting bigger, and you're decreasing if you're getting smaller. Now, mathematically, that's not quite good enough. So graphically, let's just take a quick example. So I'm going to draw here a quick graph. And so I'll draw here a parabola, something like this. Okay, so where is this function increasing? Well, it's increasing whenever the y values are getting bigger. And by that we mean if you plug in bigger values of x, are you going up? If so, that's increasing. Or are you going down? That's decreasing. Okay, so according to this definition then, the increasing stuff is all of this over here, which I'll sort of shade in blue. And the decreasing stuff is everything over here, which I'll shade in red. Okay, so if this is the graph of some function f of x, we would say that f is decreasing. We'll do that one first. And we need a number here, so let's call this a, wherever it is. It's decreasing for all the x values to the left of a. And so what interval is that? That's minus infinity up to a. Okay, so that's this stuff here. And we'll color that red. And then the set on which it's increasing is the blue stuff. Okay, so f is increasing on from a to the right. So that would be from a to infinity. Okay, so graphically this is pretty easy to tell if you have a nice function. But what may not be quite so obvious graphically is where the transition point is from increasing to decreasing. Now, you've probably noticed just looking at the graph that this number a is actually a critical point of this function. And so that's how we'll actually find these things in practice. Okay, so we have sort of the intuitive idea over here, and then now let's look at the more precise stuff. Okay, so our definition for increasing and decreasing is f is increasing whenever the derivative is positive. Okay, now back to our function over here. That makes sense because the blue stuff, where we said it was increasing, if I drew tangent lines, they would have a positive slope. And so that means that the derivative is positive because the derivative is the slope of the tangent line. Okay, and then f is decreasing whenever the derivative is negative. And then the point where it transitions between these two is when the derivative is exactly 0, and we've already given that a name. We call those places critical points. Okay, so the critical points are going to play a role here for how we figure out which sign this thing has. Okay, so let's take sort of an example function. And I'm going to do negative x plus 1 squared. Now we could graph this pretty easily. It's just a parabola that's been shifted 1 unit to the left and then flipped vertically because of the negative that's out front. And that's very simple to graph. And so go ahead and do that if you want, just sort of on the side. But let's see how we would work this and figure out whether or not when the function's increasing and decreasing without drawing the graph. Okay, so the first thing I need is something to do with the derivative. So I'll go ahead and take the derivative. And I get negative 2 x plus 1 to the first times 1 by the chain rule. And so I'll just go ahead and do negative 2 times x plus 1. Just ignore those ones. Okay, so this function is my derivative. The critical points are whenever f prime of x equals 0. And so I'm going to take my derivative and I'm going to set that equal to 0. So negative 2x plus 1 equals 0. And that clearly means x is negative 1. So that's my critical point. Okay, so at this stage what I'm going to do is just something to help me organize my thought. So I'm going to draw a little number line. And on this number line, I'm going to put the dot here for my critical point. So I'll put negative 1 right there. Now that divides my number line into two regions. The stuff to the left of negative 1 and the stuff to the right of it. Okay, so I'm going to sort of put little parentheses here to divide. Okay. Now, on each of these intervals, the function is either increasing or decreasing. We just don't know which one is which. Maybe it's increasing over here and decreasing here. Maybe it's the other way. Maybe it's increasing on both of them. We're not sure. Okay, so what is a good idea here is let's actually pick 2 points, one out of each zone. And you get to choose the points so that they're convenient, so you might as well make the arithmetic easy. 0 is clearly the point to pick over there. And then over here, I'll just pick negative 2. Okay, so what I'm going to do with these two numbers is let's work on the green one here first. F of minus 2, and not f, but actually f prime is what I care about because the definition involved the derivative here. I just need to figure out whether or not this thing is positive or negative. So if I plug negative 2 into my derivative, I get negative 2 times this stuff is negative 1. That's equal to 2. Now I actually don't care it's equal to 2. All I care about is the fact that that's positive. Okay, so you don't actually have to really do the arithmetic so much as you just have to determine whether or not you've got a positive or negative derivative. Okay, so this means f is increasing on this interval. This interval goes all the way from minus infinity up to negative 1. Okay, now we need to do the same thing over here in the second zone. So we say f prime of 0 is negative 2 times 0 plus 1, and that's negative 2. This is clearly negative. And so f is decreasing on this interval, which starts at negative 1 and continues all the way to the right to infinity. Okay, now this number line thing is really just something to help us kind of organize what numbers we're picking. And this gets a little bit more exotic if the function you have has more than one critical point. In our case, there was only one here at x equals negative 1, and so that divided us into just 2 zones. But if we had more critical points, we'd be dividing into more zones, and we'd have to do a little bit more points to identify exactly what's happening on each interval. So we'll look at some more exotic examples of this in class, but for now, basically the two takeaways here are the picture stuff says exactly what you think it does, and what the formal definition is using the derivative for when we don't have pictures.